In the last video, we defined consumer and producer surplus using an integral. In this video, we'll do an example of finding both. For this market, where the demand function is 2000 over x plus 1, the supply function is 5 over x plus 1, we'll be looking for the equilibrium point, and at that equilibrium point, we'll find the consumer surplus and the producer surplus. Alright, so I want to find the equilibrium point first. That's when the two curves meet, coincide. So I want d of x to be equal to s of x. I'm going to multiply both sides by x plus 1. Now I'm going to divide by 5. Now here you could actually expand and use a quadratic formula, but that would be longer than just taking roots. So plus or minus root of 400. That's 20, so plus or minus 20 equals x plus 1, so x is either minus 21 or 19. Now remember that x with a number of units sold, the negative number makes no sense. We're only looking at positive x here, so this one makes no sense. And so the only answer would be that x0 is 19. And remember the equilibrium point has both coordinates, so I need to find the price as well. P0, I could use either, I guess they're both the same. So d of 19, that's 2000 divided by 20, that's 100. And so the equilibrium is 19,100. So 19 units at a price of $100. The units are not given in this case. We're assuming dollars, but they might be thousands of dollars. And the same thing here, the units are not given. It could be grams, kilograms, number, thousands, we don't know. In B, we want to find the consumer surplus. Alright, so how much consumers are willing to pay minus how much they actually paid. That's how much each of them saves. And if we take this integral, we'll have the total savings of all consumers together. D of x is 2000, x0 is 19. D of x is 2000 over x plus 1. P0 is 100. And so we get 2000 log of x plus 1, absolute value, minus 100x from 0 to 19. So again, FTC2 tells you to plug in 19 first and then subtract what you get by plugging in 0. And so I'll get 2000 log of absolute value of 19 minus 100 times 19 minus log of 1, so 2000 ln of 1 minus 0 ln of 1 is 0, so what we get is 2000 ln of 19 minus 1900, 1900. In real life situations like this, when we have a context, we need to give a real life answer as well. So let me compute this. It's 2000 log of 19 minus 1900. I'm getting 3988.87796. All right. So now, since this is a real life number, there's a certain rules to rounding it. If you're thinking dollars, then you keep up to the cents. Afterwards, you round. So my answer would be that the consumers are saving let's say they're paying $3,988.88 less than they were willing to pay. All right, so if your answer is in dollars, I would round to the closest cent, so 2 decimal digits. Now let's do the producer surplus. Now this is how much people are getting, so how much the producers are being paid, minus how much they were willing to be paid. So you can think of this as their profit. If their bottom line, the lowest price they would sell would be cost, and this is how much they're making. P0, this was 19, P0 was 100. Let me double check. Yeah, 100. I had 5x plus, let's distribute, so 5x plus 5 dx. So if I simplify this, I get the integral from 0 to 19 of 95 minus 5x. So that's not a hard integral. I get 95x minus 5x squared divided by 2 from 0 to 19. Again, you plug in the top bound first, and then you subtract what you get by plugging in the bottom bound. So in this case, it's 95 times 19 minus 5, 19 squared divided by 2, minus 0, minus 0. This one I have computed here. Let's double check what we would have gotten with our phone. So 95 times 19 minus 5 times 95 squared divided by 2. I get 519. I knew I was wrong because I got a negative number and that would make no sense here. Alright, so now I'm getting 902.5, so really $902.50. And so the answer the producer are getting at this equilibrium price $902.50 more than they were willing to get. Right, so it's important to know the formula, it's important to know how to compute it, but it's also important to know how to phrase it in a way that's correct.